Hey everyone, this is Patrick Sackett. I'm displaying today for you my final submission for my malware analysis class at Dakota State University. This is a little something I like to call .NET dump. So here we have our example target VM. This is just a Windows 10 image, 64-bit. I have a few windows open which I'll go over. Firstly, we can see in our File Explorer over here, Documents, I have what would be considered a simulated payload, although a bit modified. We have a few files in here, right? So firstly, our execute bat script, which is what we're going to be using to kick off our payload. PS exec, this is straight taken from system internals. So if you're unfamiliar with that, you can find the system internals toolkit from Microsoft Windows. Next, we have our .NET dump .NET executable. And then finally we have our calcache executable, which is actually just a binary that is compiled with PyInstaller from Python to an exe. This way we don't have to rely on Python on the target machine. And then it's also more difficult for the user to reverse engineer and abstract what we're doing with everything we gather on target. So above this window we have both debug view. For the time being I have debug print statements on, at least in our .NET program, so we can kind of trace what's going on. And then over here we have process monitor. So here I have some filters actually active, primarily being for process name. So we can see we are filtering for our calcache binary and our .NET dump binary running. So we'll be capturing all the events that those programs take part in, files they open, registry keys they read. So we can quickly kind of get a glance and overview to see how they're functioning and what they're doing to the target machine. So first we'll go ahead and run our execute script. So our batch file, all we're really doing in our batch file, right, is executing our .NET dump executable with PS exec. So this is going to allow us to run a system, which is required for touching some of the registry keys we need access to in order to decrypt password hashes. And then we're finally just going to run our calcache executable and pause for input. So our calcache executable is going to take all the information that's dumped from our .NET program and parse all of that, do the decryption so that we can dump all the password hashes on the target machine. So firstly, we can go ahead and start capturing with process monitor, and then we'll go ahead and capture as well with debug view. We can see we're capturing global Win32 events as well as kernel events. So as soon as we execute this, we're going to see a lot of information start popping up. So let's go ahead and execute. First, we'll see our .NET executable executed. We see our debug print output. We see all of this action is taking place both from .NET dump and our calcache executable. So we can go ahead and stop capturing traffic on both of these windows, and we can see that's finished. So at this point, we can go ahead and start actually probably with the debug view here. So we see from our dump, our .NET dump executable, we're generating keys, we're parsing all users on the machine. So we see there are 5 total users, we're printing their identifiers, we're grabbing a boot key value for the machine itself, along with a unique F key value we'll read from the registry. And then we dump all the user information. Each user's essentially password is dumped to a separate text file, and then we dump the boot key out to a separate file as well as the F key value. The output from the calcache executable is not seen here, but we'll be able to glance at that over here in the process monitor. So hopefully this is at least somewhat large enough to view, but we see firstly we have a lot of events from our .NET dump executable. As we can kind of expect, we see a lot of registry activity. We see some of the user IDs that we may be parsing. We see some interaction with the file system as well, because obviously we are writing out all of our input from the registry keys. See some of the same user IDs that were output in our debug view, as well as some of the values we need to construct our boot key. If we scroll a bit further down, we can see our calculate hash executable. We can see we're touching the CryptoDome module because obviously we're doing a lot of decryption, a lot of just touching files, loading DLLs, and then also writing all of our output out to the separate txt file. All of this will pretty much culminate in a result.txt file. We can see here our boot key file, our F key file, all of our user ID files, and finally it'll kind of culminate in this results file that we print all the password hashes to. And we can see as well we're writing all these files to this syswow64 directory. So if all this is correct, we can actually go ahead and open up this directory. So syswow64, and then we create our own directory. We just call it out for the time being. We can see all of our user ID values. We can open this so you can see the V keys that we dump for each user. Each V key will have the user's password. You can see the boot key we construct. We can see the F key value we grab from the registry as well. And then finally, the goodies, we see our results file. So here, minimize these. We can see a few things. Firstly, we see the username on the far left, separated by a colon. We'll see that user's RID value, and then next we'll see the LM hash of their password, followed by the NT hash. So it is an NTLM password, or NTLM hash, but here it's reversed. So it's LM hash followed by NT hash separated by a colon. And we see we have all 5 of our users here. If, for those who may be paying closer attention, you might notice that all the LM hashes are actually the same for all the users, and this is primarily because, starting with what I believe is Windows Vista, Windows by default does not calculate LM hashes because they are so easily crackable, so they do that as a security measure. Should be noted you can turn them back on through some registry settings, but it's heavily not recommended. We also see some of the NT hashes are the same between some of these accounts, right? So some of these accounts don't have actual passwords set up, besides really this PSAC account obviously has a unique hash, and then also it seems like this utility account also has a unique hash. So in order to verify that our output is actually correct, we can use a separate program. Here we have what is secrets dump, or specifically secrets dump from a GitHub project called Impacket. So Impacket implements all of these different network protocols, and especially for Microsoft network protocols in Python, and they provide some helper scripts. So one of those helper scripts is secrets dump. So secrets dump is pretty much going to do the same thing as we did with our .NET executable, except it does it in a different way. It actually uses a remote registry service available on Windows, assuming you're doing this remotely. So it can connect with user credentials you provide, turn on the service, and then it actually pulls the SAM hive and the system hive down to go ahead and parse locally. So instead of what we're doing, which is parsing registry keys out of the registry on target, this program would simply just dump those entire hives from target to your local machine and parse them locally. So we see I've gone ahead and just saved our system and SAM hives locally, and I'm going to tell secrets dump that we want it parsed locally, and we can go ahead and verify here that the output is pretty much identical, right? All the LM hashes here on the same. You can see your unique NT hash for this PSAC account lines up, and then the same with her WGA utility account. As far as an overview for .NET dump, that's pretty much all it encompasses currently. Obviously there's a lot you could do with this and a lot of different directions you can go with it, but that's about wraps it up. Thank you.